Hello students, in this lecture we'll learn how to find centroid of the composite length of bent wire or bent rod. In my initial lectures we had learned how to find centroid of the composite area or centroid of the lamina of uniform thickness. Now we will learn how to find centroid of the wire of uniform size and made up of one material which is bent into certain shape. Now, to find the centroid of the composite length of bent wire, it can be assumed to made up of some simple lengths like this. In this case, we have taken a composite length which is bent into three parts in this way. AB is a straight inclined length, BC is a horizontal straight length, and part CD is bent into the shape of the curve. Let L1 be the length of part AB of the wire, L2 is the length of the part BC, and L3 is the length of the part CD. Coordinates of centroid of part AB are x1, x2, x1, y1, part BC, x2, y2, part 3, that is CD, that is x3, y3. All right. It is being assumed that this bent wire ABCD is made up of one material that is having density gamma. Material density of the material of the wire is gamma. R is the radius of this wire. We are assuming that this wire is made up of same size throughout. We are also assuming that it is made up of same material. Now, looking at our previous understanding, if you want to find the x coordinate of CG, initially we start with, if you want to find the x coordinates of CG of this wire, so how will you find it? X bar will be equal to M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3. What is M1? Mass of wire component AB. M2 mass of wire component BC, and CD is mass of wire component CD. All right. X1, X2, X3 are the x coordinates of the part AB, BC, and CD respectively. Now, we know that wire is nothing but example of cylinder. Wire is nothing but example of cylinder. What is the volume of a cylinder? Pi r square h. So what will be the volume of part 1, part AB of length L1? Pi r square L1. What is volume of part BC? Pi r square L2. What is volume of part CD? Pi r square L2. Hence, what will be the mass of first part AB? Pi r square L1 is its volume into density. Right? M2 will be volume into density. Pi r square L2 into gamma. M3 is pi r square L3 into gamma. Now, x bar. Substitute value of M1, M2, M3 into this formula. Pi r square L1 into gamma x1. This is M2 pi r square L2 into gamma into x2. Pi r square L3 gamma x3. Similarly, in the denominator, pi r square L1 M1 into gamma plus pi r square L2 gamma plus pi r square L3 gamma M1 M2. Now, from the numerator and denominator, I can take common pi r square gamma. You can see that pi r square gamma. Similarly, from the denominator, pi r square gamma is taken common. Then you see that pi r square gamma gets cancelled. Numerator is left out with what? L1 x1 plus L2 x2 plus L3 is divided by L1 plus L2 plus L. Or we can say summation Lx upon summation L. Similarly, we can find y bar is equal to summation Ly upon summation L. Now, students, to find the coordinates of CG of the bent wire, you don't need to know about its material. You don't need to know about its mass and all those properties. Simply based on the centroid of the length, we are in a position to arrive at the coordinates of centroid. Right? Coordinates of centroid. Now, here I've written a note. This shows that CG and centroid of the bent wire will be identical. Identical means will be coinciding. If the wire is of same radius or same size and it is made up of single material. That means x and y coordinates of centroid of bent wire and CG of the bent wire will be same. So CG and centroid will be coinciding. CG once see centroid will be marked on the surface of the wire, and CG will be inside the wire at half thickness. That means inside the wire from the surface at radius r. So we will be finding the centroid coordinates of the composite length of the bent wire using these two formulas. X bar will be summation Lx upon summation L, and y bar will be summation Ly upon summation L. Now, we will understand how to find centroid of the wire which is bent into the shape of circular arc. Here we are considering a wire which is bent into the shape of a circular arc, which is subtending angle 2 alpha at the center. We have taken this wire, which is you are seeing with the thick black line, all right, which is we have assumed that it is symmetrical about x-axis. If this given wire arc is symmetrical about x-axis, y bar for this will be 0. Y bar, y coordinate of centroid is circular arc will be 0. To determine x bar, we consider elemental length dl, which is subtending angle d theta at the center, so that this elemental length dl will be r d theta. All right, and then x and y coordinates of centroid of this elemental length. See, this centroid is here. So x coordinate of this is radius r, and this angle is theta plus d theta. So r cos theta will be its x coordinate, and y coordinate will be r sin theta. Anyway, y coordinate of elemental length is y coordinate of centroid of elemental length is not required, because we have already understood this. If this arc is symmetrical about x-axis, y bar for y bar is 0. So to find x bar, we will take help of integration. dl is elemental length into x coordinate of centroid element length divided by dl. Then integrating numerator and denominator. If you integrate the numerator, you get it summation lx. If you integrate the denominator, you get summation l. Now you substitute the values. Now in the numerator, elemental length is r d theta, x coordinate is r cos theta divided by r d theta. Integrate. Now as you are integrating with respect to theta as d theta, you are understanding you are integrating with respect to theta. Theta is being measured from x-axis. To cover the entire arc length, lower limit will be minus alpha, upper limit will be plus alpha. Then the entire arc length centroid will be centroidal coordinate x bar will be off. So lower limit is minus alpha, plus limit is upper limit is plus alpha. Now r square is taken common. Inside the integration cos theta d theta. So you are integrating cos theta with respect to theta. And from the denominator, you are taken r common, and you are integrating the 1 with respect to theta. So here then what it comes, r square upon r, you get r. Cos theta is integration sin theta, upper limit alpha minus alpha. And it is 1, so that is theta alpha minus alpha and minus alpha the limits. Then alpha, this becomes sin alpha minus sin alpha, this is 2 sin alpha. Alpha minus minus alpha 2 alpha. 2 gets cancelled, it comes out to be r sin alpha upon alpha. Now this for this circular arc, where it is symmetrical about x-axis, y coordinate of centroid of this arc is 0. That is y bar is 0. Since centroid of this circular arc will be lying on x-axis. But x coordinate of centroid of this circular arc will be lying along axis symmetry, and it is r sin alpha upon alpha. But if you have any other, now you want to apply this formula to locate the centroid of any other circular arc. So you should remember that for any circular arc, centroidal distance r sin alpha upon alpha is measured along axis of symmetry. It is absolutely identical to what we learned about the circular sector. In the circular sector for the centroid of lamina, we had understood that central distance 2 by 3 r sin alpha upon alpha is measured along axis symmetry. Similarly, for any circular arc, centroidal distance is measured along axis of symmetry. Right? Here, alpha is semi-angle of the arc. Alpha is semi-angle, half angle of the arc. Now, we'll apply this formula to arrive at the centroid of semicircular arc. Just see that. This is your semicircular arc. All right. This is measured along axis of symmetry. So this distance x bar will be equal to r sin alpha upon alpha. Alpha is 90 degree or pi by 2. Degree, it in degrees, alpha is half angle of this. Total angle subtended is 180 degree. So half angle alpha is 90 degree or pi by 2. Right. So x bar is r sin alpha upon alpha. Here we substitute in degrees for the ease of calculations. Because if you substitute here in degrees, radians pi by 2, then you have to change the mod of the calculator to radian. If you want to keep the mod of the calculator in degree mode only, as we normally keep the mod of the calculator in degrees only. So here you can substitute in degrees, and here you can substitute in radians. All right. So x bar is obtained as 2r upon pi, and y bar will be 0 for this circular arc. Now come to this quarter circular arc. This quarter circular arc will be subtending angle 90 degree at the center. Along the axis symmetry, centroidal distance will be measured. So OG distance is going to be r sin alpha upon alpha. Alpha is half angle of this quarter circular arc, that is 45 degree or pi by 4. Right? In the numerator, we substitute the value of alpha in degrees and denominator in terms of pi and radians. So this comes out to 4r upon pi into 1 by root 2. But this is along axisymmetry. Normally, when we solve the problems, center distance is measured along the base. All right. So we resolve this distance. What will be x bar? OG cos 45. What will be y bar? OG cos 45. So OG is 4r upon pi into 1 by root 2. Cos 45 is 1 by root 2. So it comes out to be 2r by pi. So this way we prove that centroid of quarter circular arc is at a distance of 2r upon pi from each base. From this base 2r upon pi, from this base also 2r upon pi. Now here just we are have put the different shape of the wires what we come across while solving the sums into just as a formula sheet, you can call it. This is, you can call it as a formula sheet for solve before we apply the formula into the problems. Now suppose we have a bent wire which is straight horizontal line. So of course the centroid of this wire will be, or line will be mid length L by 2 L by 2. Suppose we have the straight inclined length of L, so again it will be L by 2 L by 2. Suppose this inclined length we form a right angle triangle with this length as hypotenuse. So from the centroid of this, from the center of this inclined length, if we draw perpendicular on the two sides, these two sides will be divided into half and half. So this is the property of the geometrical property. We have learned it in right angle triangle. From the center of hypotenuse, if we draw perpendicular, the two sides meeting at 90 degrees, those two sides are divided into half and half. All right. This is what we need to remember. This property will help you in reading the coordinates in x and y directions for the inclined lines. Then we take semicircular arc. Your wire is bent into the shape of circular arc. You'll remember that centroid of semicircular arc lies along axisymmetry, and it is at a distance of 2r upon pi. What is the length of semicircular arc? Pi r. Then we come to quarter circular arc. For quarter circular arc, centroid of quarter circular lies at a distance of 2r upon pi from each base. All right. And what is length of the quarter circular arc? Pi r by 2. So with this, students, we are ready to start with the problems. Let's take up the first sum. Locate the CG of bent wire of the uniform section as shown there. This is CG, locate the CG, or they say locate the centroid. You have to understand it one and the same thing, because they will be giving to you only length properties, right? You will be finding only x bar and y bar. All right. So whether they say locate the CG or locate the centroid, we have to understand one and the same thing for as far as the solution of the problem is concerned. So you have this time the bent wire, which is in the form of AP straight length plus this semicircular arc plus this straight length CD plus quarter circular. All right. Now we need to draw the diagram again. In this diagram, we will take up into 4 parts. One is straight horizontal length AB, semicircular arc BC, straight length CD, quarter circular arc. Inclined length CD is not given directly, but we can understand it. This is using Pythagoras theorem. CD length will be 30 square plus 20 square root of. So it comes out to be 36.06. Now I have marked the centroid of each component, right, in the diagram. This is length AB, right? It is coinciding with x-axis. It's of length 60. So centroid will be at 30 mm from each and AN. I have marked it as a big dot. Then we come to the semicircular arc. Centroid of semicircular arc lies on axisymmetry at a distance of 2r upon pi from base. This is a base, so 2r upon pi. This is it. Okay. Then we come to this inclined length. This inclined length centroid will lie at the center of this inclined length. But if you drop perpendicular on this side and this side, this is 30. It is divided into 15, 15. If you drop perpendicular on this side, this 20 mm, this projection will be divided into half and half. So this way, division of the projection will help you in reading the coordinates. Then we come to quarter circular arc. For this quarter circular arc, centroid will lie at a distance of 2r upon pi from base. This is 2r upon pi. This is 2r upon pi. Now, working is done. Centroidal working is done in a tabular format to find x bar and y bar. We directly do not substitute the values of use the formula directly. We do the working in the form of a tabular format. Now here there is no axisymmetry on this bent wire, so we need to find x bar and y bar both. So we make a table with 6 columns: component, length, x coordinate, y coordinate of length, L into x, L into y. All right. L will be, length will be in mm. Here it's a unit. X is in mm, y is in mm, Lx and Ly will be in mm square, mm square. Now AB. This is length AB is it's of 60. All right. So x coordinate is measured from y-axis. It's right of y-axis by 30. So x coordinate is plus 30. Y coordinate will be 0 because centroid of this part of the wire AB is lying on x-axis. So y coordinate will be 0. Then we come to arc length BC. Right. BC part, its length will be pi r. Pi r is 15, 47.1. X coordinate is measured left of y-axis, that is minus 2r upon pi. R is 50, minus 9.5. Y coordinate is measured from x-axis, so it is above centroid of this semicircular arc is above x-axis by 15, so plus 15 will be y. Then we come to CD length. This is we found it 36.06. Right, x coordinate is measured from y-axis. Centroid is right of y-axis by 15, so plus 15 is x coordinate. Y coordinate is measured from x-axis, so 15 plus 15, 30 plus 10 will be y coordinate positive since it is above x-axis. Now length D, quarter circular arc. Quarter circular arc, its length will be pi r by 2. R is 30, pi into 30 by 2. Right, centroid distance. Centroid of quarter circular arc is at what distance from y-axis? It is right of y-axis, x coordinate is positive. How do you get it? 60 minus 2r upon pi will be x coordinate positive. Y coordinate of centroid of circular arc will be positive since centroid is above x-axis. Y coordinate is 50 minus 2r upon pi. You got it 40.9, 30.9. Rest all you will do the calculation. L into x will come in this column for each component. L into y will come in this component. Then we carry out summation of all components, that is summation L. Summation of this column will give you summation Lx. Summation of this column will give you summation Ly. So now you will apply the formula. X bar is summation Lx upon summation L. Summation Lx we have found it 3817.83. Summation L is 190.3. This comes out to be 20.06. Y bar is summation Ly upon summation L. Summation Ly 3605.2 upon 190.3. This comes out to be 18.94. So this way, x bar and y bar are x and y coordinates of centroid of this composite length of bent wire. Okay. Ready to move to the next sum. Find the centroid of the bent wire shown in the figure. This time, this is your bent wire ABCD. AB is straight horizontal length, BC is semicircular arc, CD is straight length. All right. You are given with origin as this point. X and y axis are shown. Okay. Now we can draw the diagram again. I marked here this is origin X and this is Y. X and Y axis were given in the problem. Right. Now we mark the centroid of each component. AB is length 8, so centroid will be at 4 centimeter. This is semicircular arc. Centroid will lie on axis symmetry at a distance of 2r upon pi from base. This is inclined length 8 centimeter. Its horizontal projection will be 8 cos 30. Its vertical projection of this inclined length will be 8 sin 30. Centroid will be at mid length 4 centimeter from each side. It will, if you drop perpendicular, it will divide the projection into half and half. This property will help me in reading the coordinates. Again, the given wire length does not have any axis symmetry, so I need to find x bar and y bar both. So make a table with 6 columns. Component L, X, Y, Lx, Ly. Dimensions are in centimeter, so L is in centimeter, X is centimeter, Y is centimeter, Lx is centimeter square, Ly is centimeter square. Now length AB. This is straight length AB 8 centimeter. Coordinates of centroid of this point will be this point. Centroid of AB is right of y-axis, so x coordinate is positive 3 plus 4 7. This centroid is above x-axis, so y coordinate is positive, that is 9. Now BC length, arc length. Length is pi r, r is 7. You got 20. Now this is centroid of semicircular arc. This point is right of y-axis, x coordinate is positive 3 plus 8, that is 11 plus 7, 18. Y coordinate is measured from x-axis. Is it above x-axis? 9 plus 2r upon pi. Length CD is 8. X coordinate of centroid of this is the centroid of this. X coordinate will be what? Point is right of y-axis. X coordinate is positive. 3 plus 8, 11. 11 plus 14 is 25. 25 plus 8 cos 30 by 2. That is 4 cos 30. Y coordinate is measured from x-axis. This vertical projection of this is 8 sin 30. From here it is 9. So 9 minus 4 sin 30. 9 minus 4 sine 30 will be y coordinate of this point with respect to x axis. Rest all is students calculations. You'll get it L into x of the product of these two columns will be Lx, L into y of all the four components will be Ly. Summation Lx will give you, this is summation Lx, summation of this column. This is summation Ly, summation of this column will be summation L. Now use the formula x bar is equal to summation Lx upon summation L. Substitute the value of summation Lx 679.68 upon 38, 17.886 centimeter. Y bar is summation Ly upon summation L. Summation Ly is 424.12 upon 38, 11.16 centimeter. All right. Let's move to next problem. Third problem. Determine the center of gravity of the wire ABCD of the uniform weight of 2 kilonewton per meter bent as shown. He is asking center of gravity. Determine center of gravity means locate coordinates of CG or coordinates of centroid. As there is no other information is given, you have to find only x bar and y bar. Now look at this bent wire assembly AB, BC, CD, and D. Now you can see that this composite length of the bent wire is symmetrical about x-axis. So directly I can say due to symmetry y bar is 0. So one answer is obtained. Then you have to find only x bar. If you have to find only x bar, you need to make a table with 4 columns. Can you see that your component, length, x, and lx. Units are in mm, so length is in mm, x is in mm, lx will be mm square. Now there will be 4 components AB, BC, CD, and D. AB arc length AB and D are identical. Even BC and CD are also identical. This is the diagram what has been given. We draw the diagram again with little bit the scale. Then for the arc AB or DE arc, radius is 50 mm, you understand. Total angle subtended is 60 degree or pi by 3 radian. 180 degrees pi radian, 60 is pi by 3. Alpha is half angle, 30 degree or pi by 6 radians. Length of this arc is r theta, that is 50 into pi by 3. Right? You got length of this arc. Centroidal distance which is measured along axis symmetry is r sin alpha upon alpha. In the numerator here we'll substitute alpha in degrees and here in radians, so that I don't need to change the mod of the calculator. So it comes out to be 47.75 mm. Now we have made the table. All right. We can also understand due to symmetry, this is angle 60, this is 30, this is 60, 30. So you can understand that if this radius is 50, this BC is also 50. This is 50, so this is also 50. That's what we can easily understand. Now we can start with arc length AB. I'll start first component. Its length is 52.36. What will be about its x coordinate? This centroidal distance, what you calculate, 47.75 is measured along axis of symmetry. Axis of symmetry means what? This angle is 30, 30. So you can form a right angle triangle here of this distance as hypotenuse. So its adjacent will be 47.75 cos 30 and opposite is 47.75 sin 30. So 47.75 sin 30 becomes x coordinate, which is measured from y-axis, right of y-axis. So plus 47.75 sin. Then length BC is 50. Its centroid is at mid of this inclined length. Drop perpendicular. This projection is divided into half. This is, since it is length is 50, projection will be 50 cos 30. Half of this projection is 25 cos 30. Similarly, this is 50, this is 30. So this projection is 50 cos 30. So x coordinate of centroid of this straight inclined length is going to be 50 cos 30 plus 25 cos 30, that is 75 cos 30. So x coordinate of centroid of this inclined bent wire is 75 cos 30. Similarly, for this wire CD, it is 75 cos 30, right? And the length of the wire CD is 15. Now we come to arc length D. It is again 52.36. X coordinate of centroid of this wire is again going to be identical to what we learned it for AB, 47.75 sin 30. Then this is summarized. You get summation L, L into X. This is summarized in this column, summation LX. X bar is going to be summation LX upon summation L. Substitute the value of summation LX and summation L, you get it value of X bar. Okay, let's move to the next sum. Let's read the next sum. A thin homogeneous wire of uniform section is built into the shape as shown in the figure. Determine the position of CG of the wire. Now, this time, students, you are given with a wire which is bent into this straight length, then this is circular arc, and then again straight length. So you can say that there are three components. One is straight length, straight and inclined length, this one, and this one. These lengths are equal to radius only, and this is circular arc. All right. Now I take origin is given as center of this circular arc, x and y. Okay. Now we understand this length OA and OB will be r. Centroid will be at r by 2. This angle is 30. So this half of horizontal projection of this inclined length will be r by 2 cos 30. Again, I repeat, this length is r, this length is r. Centroid is at r by 2 from center. If you form a right angle triangle, this will be r by 2 cos 30. Right? So even we should also understand that this composite length of the bent wire is symmetrical about y-axis. So x bar will be 0. What will be that? X bar will be 0. So due to symmetry, x bar is 0. This is one answer. So here also you have to find only y bar. So you need to make a table with 4 columns, component L, Y, and Ly. Right? No unit should be written because he has not given any dimensions in the problem. Now, we understood for the straight lengths, that is OA and OB. Length is r, y coordinate is r by 2 cos 30 for this above x-axis, r by 2 cos 30 above x-axis for OA also. Right? Now we come to this circular arc. This circular arc is subtending angles at the center as 300 degree. So circular arc, theta is 300 degree, 360 minus 60. 300 degree into pi upon 80, 5 pi by 3. Alpha will be 150 or 5 pi by 6. R into theta, R into 5 pi by 3 is 5.236. R sine alpha upon alpha. R sine 150. Alpha here in numerator in degrees, here in radians, you get 0.191. So arc length. Length is 5.236. Y coordinate. Now, this centroidal distance of circular arc is measured along axis of symmetry. It is measured along axis of symmetry. All right, from the center. Major length of this circular arc is below the center, so it will be measured below. So this distance, which we have marked it of the centroidal distance of the circular arc, is 0.191. So coordinates of this point, y coordinate of this point will be minus 0.191 r. All right. So L into y minus r square. L into y for this is 0.43 r square. For this 0.43. So summation Ly is minus 0.134 r square. Summation L is 7.236. So y bar is what? Summation Ly upon summation L. Substitute the value of summation Ly and summation L. You get the y coordinate, that is minus 0.0185. So this way, in last two problems, we understood the role of symmetry also. If there is axisymmetry in the composite length, then your half job is done. Like in this problem, the given composite length of the wire is symmetrical about y-axis, so x bar is 0. Right? Okay. Now we come to one more problem. We will be discussing it. Figure shown is formed of a thin homogeneous wire. Find the length L of the portion C of the wire for which CG of the wire is located at C. He says that you have the composite length of the wire. This is straight length DE, which you can split it into two parts, DC and CE. Then you have the arc, which is subtending angle 60 degree at the center C. Now we can understand that unknown dimension in this problem is in x direction. So answer will come based on x bar. Also, we understand that given composite length is symmetrical about x-axis. So if I take C as origin, this is x-axis, this is y-axis. So we can say that given wire is symmetrical about x-axis, so y bar is 0. But in this problem, we don't need to apply that also, because he has already he is asking you to find the length of the part C for the condition that CG is coinciding with point C. So that means C is origin. C is origin, and we have taken C as origin, and C is centroid of this bent wire also. So x bar and y bar, if you solve this problem with C as origin, x bar and y bar will be 0. So I have written here in the solution, choosing the C point as origin or two reference axis, and that means x bar and y bar both will be 0, because he has already given to you is that Centroid of this bent wire length lies at point C. Now, as unknown dimension is in x direction, we will work for x bar. So now we understand that this is length L, so its centroid will lie at 0.5 L. This length CD is R, centroid will lie at R by 2. This arc, we need to find its property. For this property of circular arc AB, total angle subtended 60 degree or pi by 3, half angle alpha 30 degree or pi by 6, length is R theta, R into pi by 3, 1.047. R sin alpha upon alpha, alpha is 30. You are right in numerator, substitute in degree, here in radians, so 3R by pi, 0.955. All right, now come to the table. Component, length x and Lx. So only instead of L, I have used the notation as L dash, because L is the notation used in the problem. Arc length AB, its length is 1.047 R. X coordinate is measured left of, it is measured along axis symmetry. It is will be left of origin, so x coordinate will be negative. What will be that? Minus 0.955 R. Length CD is R, x coordinate will be 0.5 R, left of y-axis minus 0.5. Come to length C, length is L, x coordinate will be plus 0.5. Then this product of this column and this column will give you L dash into x. If you carry out summation, this is summation L dash, this is summation L dash x. We understand x bar is 0, summation L dash x upon summation L dash is equal to, this is summation L dash x. What is that? 0.5 L square minus 1.5 R square upon summation L dash, that is 2.047 R plus L equals 0. Denominator gets merged with 0. So you get it 0.5 L square minus 1.5 R square equals 0. Or L square is equal to 3 R square, or L is equal to square root of 3 R square, or 1.732 R. So this way the length of part C is needed is 1.732 R, so that CG of this bent wire will coincide with hinge C. So this way we have learned the theoretical concepts, how to find the centroid of bent wire or composite length of the bent wire, and we have also understood how to solve the problems of bent wire, composite length of bent wire. So we have discussed 5 problems. For more problems, you can refer to my book. All right. Book, this chapter is given as the last chapter in the book under the category of miscellaneous topics. Right. Check your syllabus. If it is in the syllabus, then only learn this topic, because it may be there for your syllabus or may not be there. In certain colleges, certain universities, it is in the syllabus. For certain colleges, certain universities, it is not part of the syllabus. Right. For more details, more solved problems, you can refer to my book, which is available on Amazon and on local bookstores. All right. Link of Amazon is given in the video description of every lecture. Right. Book has many MCQs, many more solved problems, and some unsolved problems. Theory, major part is definitely discussed in the lecture, but some more additional theory will also be there in the book. Right. Now, I conclude this lecture with this, and my next lecture will be on centroid of area under the curve. Okay, students, thank you.